Hi, welcome to the Introstat lecture series. And in this video, we're going to start a new unit. And this new unit is, we call it the sample survey. And, from the previous unit, we talked about the testing hypothesis, right? So we have so many different methods for testing hypothesis. But we always said when we did the hypothesis testing, we always said, let's take a sample, right? So we can take a sample from one population, two population, or even some paired data here. So for this unit, we're going to take a detailed look of what is this sampling methods here. All right. So what do we need to be careful when we take a sample, and what are the things we'll try to avoid, and what are the different sampling methods here we can use. Okay, so now let's go to our lecture notes here. Let's go ahead and start. All right, so the first things we're going to talk about is we have the three big ideas about the samplings here. So the idea number one here, the reason why idea number one is we want to examine a part of a whole. What that means here? That means, that's what we say a samples here, right? A sample can give us the information. So a sample can give the information about the population. This is what we mean. That's really is the idea number one, why we want to do a sampling, right? So the ideas of sampling is a sample can give us the information about the populations here. And then the next things here, sampling methods here, right? So for the sampling methods here, because we are taking a portion of the population by its natures, we're going to, so we have the chance to tend to over or under emphasize some characteristic. Okay, of the populations. Okay, so now we are set. So what is this under, or over emphasize, as we said, to be biased. So this is one of the biggest concern for the sampling method is this biased. So depends on what you try to do, right? So that's why, when you try to take the samples here, sometimes you're going to overestimate or underemphasize some of the characteristics for the things here. So then because of this, you are inherent to this, we call this the bias here. So then here, that's what we call the bias is the band of the sampling. So when you do the sampling, the number one criteria here you need to be careful is you want to minimize this bias, because if you don't minimize this bias, then you try to use this method, try to estimate your populations here, right? And then you're going to have the flaws when you do the estimations here. Okay, so the last things here, we said this is the things we want to avoid here. Okay, so that's why we said the bias is the number one criteria when you do a sampling here. The reason why is if you make the conclusions here, okay, based on the sample, drawn with the bias, methods here, okay, are inherited flaws, flawed here. Okay, so for example, if you are the city council member, you want to see the opinions, like for certain like land, you say, hey, am I going to use this land to build a dog park, or I'm going to use this land to build maybe the like the kids softball field or baseball fields, right? So now when you take a samples here, the first one, so you say, okay, and so you're going to, for example, a park, the regular park, and then you take the, you ask the people, you say, hey, do you prefer this one's here to be a dog park or to be a kids softball field? And if a lot of people, a lot of kids are playing in that park, so maybe of the parents will say, oh, I would prefer to be the kids' sports centers, right? But also if that park is a very dog-friendly park, if you see a lot of people running the dogs there, then you ask those people for the sampling, and then they will say, well, I would like, to build a dog park. So when you do this type of the samplings, right? So that's why, because you emphasize or you underemphasize some characteristics of the population you samples here. So that means whenever you use the sampling method is biased, and then what's going to happen? Your conclusion going to have flaws. If your conclusion have flaws, then the estimation, you try to, based on this sample data, to give some information about the population, that not going to be, correct neither, right? So that's why we say the first idea when you pick the sampling methods here, you need to, in your mind is this sample has to represent my population, right? Is my sampling methods emphasize or lean toward a certain group or certain results? And do I have inherent bias in my sampling methods here, right? So we need to remember that. Okay, so the randomize here. So the randomize here, that means, when you take the sample, you really want to kind of the randomize your sample. You don't want to, so like, for example, the dog park or the kids sports facility, you don't want to take all the sample from the park, right? So you might want to, kind of send out the general survey to ask, instead of if you take all the sample from the park, and then that's what kind of have the bias is not randomized, it's not cover the whole populations here, right? Okay, so here, let's try to put this here. So we said that not only does the randomization protect you against the factor that you know in the data, it also, the very importance here, it can also help to protect the factor, to protect against, to help to protect against a factor that you don't know. You don't know where they're. Okay, so that's why we want to do the randomizations here. So like we did some random, like we talk about so for example, if I want to do take a sample to see how many hours people study for the exams here. So I want to take like the 10 students from the class. I should randomly take, like just randomly pick the student. If, one way I can do it, since we have like 10 rows, right, in the classroom, I can randomly pick one row and then check the the study hours for that row, the students. But that is not truly randomized because also I inherent bias by doing this type of sampling. So why is that? Yeah, I randomly pick one row from 1 to 10, and I can randomly pick one row of the student. And then I check the students there, so how many hours you study for the exam. But, typically, like the students, if you are friends with other the other classmate, you have a tendency sit together, right? So then my sample like this one is not a fully randomizations here. So that's why I could end up with the bias. So if you sit with your friends, if like the friends sit together, they have either the good inference or bad inference. So their study hour could be long or could be short, right? So that's why we said the randomization is kind of important because of when you randomly pick, you can avoid that's why we say you can avoid the characteristic affecting the data. You know about it, or you can avoid, you don't even know about it, right? So that's why this randomization is kind of like the importance here, all right? So that's the second idea. So when you do the sampling here, so the second big idea is about the sampling here. You have to consider the randomization. You need to randomize your sample. So make sure you can protect your data against a lot of unknown factors hiding behind. Okay. So then the next thing here we call it is the sample size here. So the sample size is what matter. Okay. So we said that the sample size is what matters here. Okay, so be very careful here when talk about the sample size. It is the size of the sample. And not its fractions of the large population. Yeah, sometimes you have like, for example, we want to take a sample of the large university. So like some large university have the 50 or 60,000, the students, right? So we take a sample, what is the sample size? In general, the survey will give you a good information, like the survey will provide better information if your sample size is bigger. Okay, but in here we said the size of the sample, but if you are dealing with like the large populations here, right? So when you're dealing with the large population, and we don't really, we still care about it is how many units in your sample. So like if you take like 30 or 50, it's really not to the fraction of the larger population. So in general, like from the statistics point of view, the kind of the rule of the thumb, we treat the sample size like n equal to the 30, because take a sample is very expensive also. So you want to balance that. So you want to have a large enough sample size, but you don't want to spend so much money for that, right? So the special for the large population. So sometimes you take 50 data points, you say, wow, if for the 50,000 students, I only take the 50 students, is my sample okay? Right? So as long as, like your sample, the way you take it, you don't introduce any bias, and it can cover the whole populations, all the characteristic you care about. So 50 sample is okay, even if it's a very, very small portion of your large populations, right? So the same ones here, like in the 50, you know, like for the 50,000 students university, of course, if you take 100 sample versus you take the 50 sample, 100 sample probably will give you a little bit better information, but you know, probably it will be way more expensive to take like the 150. And also, if your sampling method is good, you know, you will get about the similar information by taking 50 or hundreds here, right? So the sample size is the size of the samples here. Like we say in the statistic area, typically we talk about is the, like n equal to 30. It's not a fixed number, so sometimes you can say n equal to 50 or hundreds. And so like in general, we say is a larger the size, they provide more information. And but also, of course, larger the sample costs more money here. And so when we talk about the sample size, it's the actual sample size. And then one of the questions and then people constantly ask, now how about sensors? Okay, so what is the sensors here? Sensors here, right? So let's take a look here. So sensors here. Okay, so if you include everyone, or we say you sampled the whole population. We sample the population, and such sampling is we call it is the what? Is called a sensors. Then you say, how about let's do a sensor, right? So if you can, you know, include everyone, and then that means you take a look at the whole population, you cover everything, then you don't need to worry about the randomizations, and then you don't need to worry about the randomization bias, and then like did I cover the key characteristics? So what's wrong with the sensors here? So what is the drawback from the sensors here, right? And so the number one problem here, it can be difficult to complete a sensor. And also can be very expensive to complete the sensor. That's why in the US, we only do it every 10 years, right? Because it takes a lot of efforts. And it's very difficult to complete because what could be happens here, we said, for example, some individuals, right? Some individuals in the population is hard to locate, right? So I don't know where to find them if you do a census here. And or sometimes we say it's impractical, it's too expensive here. All right. So that's why we said that the number one problem when doing a census is like very difficult to complete, especially if your population is big, right? It's very difficult, it's very expensive, and sometimes you cannot even locate everybody in the population. Okay, so what is the second problem here when we do a census here? And so because we are trying to take a sample, not to take a sample, we want to sample in everyone in the populations, right? But the typicals here, populations rarely stand still. Right? Because when you try to do the sensor, it's not to say, okay, everybody stop here, and then nothing moved, right? So the population really stands still because it's a big group, the things change every day. And so you really don't know, like try to capture everybody is very, very difficult here, okay? And so that's why we said, the sensor will takes longer to complete and the population changes right? Because the population rarely stayed still. So that's why, it's very difficult to complete. Okay, so number 3 is here, taking a sensor. Okay, so it's just, we said taking a sensor data here. Can be more complex than the sampling, because you try to take a look at everybody in the population, and you want to prevent the population is constantly change, and so you need to decide how do you do it, right? So most of the time, the sensor can be way more complicated than the sampling method. That's why sampling is a big area in the statistic area. So like if you are interested to go to the graduate school, in fact, the sampling method is 1 semester course in the graduate school levels here. So in that semester, they will talk about all different sampling method and what is the, what things we try to avoid, and how do we, check is the result is correct or not. And so that's why if your sample is doing good, it will give you, sometimes will give you the way more accurate information, and the sensor data will give you as well, because the sensor, like we say, is very, very difficult to complete. And also like, how do you dealing with your population constantly change? And the samples here, because it's a smaller group, a smaller sample you take, and sometimes will provide you a very, very good information. That's why to choose a correct sampling method is very, very important here. Okay, so now for this video, let's stop here. So this video is here. Let's recapture what we talk about. So the big 3 ideas about the sampling here. So first things you need to remember in your mind, the sample you have to represent your populations, right? So you try to avoid the bias. The bias is the number 1 thing you want to avoid, because if your sample is biased, then the estimation of the population will not be accurate, right? So here, that's why we say bias is the bane of the sampling here. Then the randomization is also play a very, very key role in the sampling methods here, because you need to randomize it, so you want to avoid systematic issues embedded in your data here. Then the third thing here is the sample size, right? So how to balance the sample size? Like we said, in general, the more sample will give you more data, but it's way more expensive. So if we push to the extreme, we say, let's do a sensor. You take a look at every number in the populations, right? So that's why we talk about the last things here. Does the sensor make sense? And in fact, it's very difficult to do. So it's difficult to do, and the population, really stand still, and it's sometimes very complicated than the sampling. That's why, in the US, we only do the sensors every 10 years, because it's not an easy task here. All right, okay, that's it. And so our next video, we're going to talk about several different sampling methods here. All right, so we're going to talk about what is a simple random sample, stratified sample, cluster sample. And then we're going to talk about for each those sample, what could be the problems we're going to deal with. All right, okay, so nice to talk to you, and looking forward to talk to you in our next video. Okay, bye.